Okay, guys, I've been asked to do U4A8, exercise 1, question 1. So what's happening here is we're going to make the left side look like the right side. The right side is left like this. The left side is this here. Secant squared x minus 2 sec x cos x plus cos squared x. So the first step here is to recognize that this is a perfect square where you have, now usually with a perfect square, what you have is a plus 2ab plus b squared, and that turns into a plus b all squared. Now the same thing holds true if there's a negative in here. So if you had this if you had a negative b in here, it would turn out to be like this. And let me explain why that's the case. Sorry, these should be squares. When you expand so this is a minus b all squared, or a minus b times a minus b, which is a squared minus ab minus ab plus b squared. So you notice that if the b is negative here in a plus b, what happens is the b squared stays positive because it's squared, and then the middle terms become negative here. So it's kind of a special case of a perfect square. It's not really a special case. It's just the fact that b is negative. So when you do that, you end up with taking this whole thing and factoring it into this here, sec x minus cos x all squared. The next step is to replace secant with 1 over cos, is reciprocal ratio, and then combine these two terms together or subtract them. Now, whenever you have a fraction and you're adding to it something that is not a fraction, so I'll do this over here, you make them both fractions with common denominator. So if I have 1 over a, for example, 1 over a plus a or minus a, so I'm just showing you here cos x replaced with a, what you do is you look at this and say, okay, what's the common denominator between 1 over a and plain old a? Well, remember that this is just a over 1, right? So the lowest common denominator will be, a. So common denominator is a. So if I want this to be a, I multiply the bottom by a, and then I have to multiply the top by a. So I end up with 1 over a minus a squared over a, which is 1 minus a squared all over a. And that's how I get to this right here. Okay, so I combine these terms together. Now 1 can be replaced by sine squared plus cos, sine squared x plus cos squared x. Okay, so that's from last year. And then this, subtract this, is 0, so I'm left with sine squared x over cos x all squared. Once I square both those, I get sine to the 4th cos squared x. And at this point, you might want to start looking at where you want to go here. Now, I have no problem. So some people have issues with this, but I have no problem doing this. At this point, you might be done here. And then what I would do over here is say, okay, look, this looks like this. Okay, I want this on the left now to look like this here, but you can look at this here and say, look, sine squared x, and I know that tan is sine squared over cos squared. Okay, and then either clean this up so it's like this. Okay, some people don't like this. They want to make one look like the other. But here I've proven that these are the same thing, and that's what you're asked to do, right? You're asked to prove that they're the same thing. So what you've done here is you've changed both of these to look like the same thing. So if you want to stop at this point here and recognize that you're almost at the same place between the left side and the right side here, you can do that. Or at this point, once you realize that's like this, you can go ahead and do what they did below and break up sine to the 4th as sine squared times sine squared. That might be a tough one to recognize, right? The only thing you're looking at here is that you have cos squared sine to the 4th, right? You break this up, you have something that can be reduced because you have the same powers here, right? They're both to the power of 2, and then maybe you get tan out of there. But this last step here might be a little bit tricky for it. Okay, hopefully that makes sense, especially what I did over here. Might simplify stuff for you. Okay, thanks a lot. Take care.